Alrighty, let's take a look here. Looks like today we're going to be talking about worksheet 10.7 and worksheet 10.8. We're going to be given an angle of rotation, either positive rotation or negative rotation, like we did with the finding what quadrant we were in. This time we're going to be given an angle of rotation in the Cartesian coordinate plane, and the student's going to find what we call the reference angle. So I'm going to define the reference angle for you and then show you how to find it. So here we go. The reference angle is the angle formed by the terminal side. Hopefully you remember that from finding quadrants, the quadrant in which the terminal side stopped. We're going to find the angle formed by the terminal side and the nearest x-axis. X-axis, not the y-axis. A lot of kids make that mistake. We're going to find the angle between the terminal side and the nearest x-axis. Okay? So here we go. This is what it looks like. We're asked to find the reference angle. We're given an angle of rotation. This is negative 665 degrees. This is the terminal side right here. And we want to find the angle that's formed by the terminal side and the nearest x-axis. That's the nearest to this terminal side. Well, this x-axis right here is closer to this terminal side than the x-axis over here. We don't want this angle. We want the nearest x-axis. So I want to know if this is 665 degrees, negative 665 degrees, what would this angle be? And it's going to be positive. We don't use negative reference angle. Our reference angle will always be a positive value. Okay? So I want this angle right here. So let's figure out what it has to be. Here is negative 90, 180, 270, 360, 540. Oh, wait a minute. Let me count those again. There's 360, 450, 540, 630. So this would have to be 35 degrees. If this is 35 degrees right here, and this is 90 degrees, then this has got to be 55 degrees right here, 55 degrees. This 55 plus 35 would make this 90. So our reference angle would be 55 degrees in this case. That is the angle formed by the terminal side of our angle of rotation and the nearest x-axis. Okay? And I'm going to count that again just to make sure I got that right. There's 360 plus 90 is 450, 540, 630, 635. Yay! Okie dokie. Let's find this reference angle. The reference angle here, I'm rotating in a positive direction, and I want the angle between the terminal side and the nearest x-axis. I'm looking for the measure of this angle right here. Okay? So what I'm going to do is I'm going to rotate. If this is a 260 degree rotation, I know that, well, from here to here is 180. How much further do I have to go to get to 260? Well, that would have to be another 80. 180 plus 80 is 260, or you can go 260 minus 180. In either event, this has to be a 60 degree angle if I do my arithmetic correctly. And let me check that real quick. Because my arithmetic early in the morning is not the best. Whoops, that's 80, I can't count. Did I say 60? Laws help me. I might have said 80 and wrote 60, I don't know. But if I go from here to here, that's 180 plus another 80 takes me to 260. So if I actually did say 60, I'm old and brain damaged. 180 degrees plus 80 degrees is 260. So I took 260, subtracted 180, and that told me my reference angle. And so I would say the reference angle equals 80 degrees. Excuse me. Okay. Let's take a look at this one. We're not given a drawing here, so I'm going to do a rough sketch. 140 degrees, I want the reference angle. Here's y, here's x, here's the origin, here's my initial side. I'm going to rotate 140 degrees. Well, here's 90 degrees of rotation, so I'd have to go 50 more to get to 140. Something like that. That's not perfectly accurate, but it gives me an idea. That's a 140 degree rotation, positive rotation. I'm in quadrant 2. I want to know what is the measure of this angle right there. That's the reference angle between the terminal side and the nearest x-axis. So if this is 140, this has got to be 40. That little angle right there has got to be 40. And again, we don't take into account positive or negative. We always call our reference angle a positive angle. So the reference angle, in this case, would be 40 degrees. That's the angle that's formed by the terminal side of our angle of rotation in the nearest x-axis. Okay? And we'll do one more, and I think I'll be done. Let's take a look. We're talking about 640 degree rotation. Going to have to learn how to count. I'm going to have to learn how to count, apparently. So here we go. We're going to rotate in a positive direction, just like we rotated in a positive direction here. I'm going to go 90, 180, plus another 90. It's 270, 360, 450, 540, plus another 90 would be 630. Then I'd have to go 10 more. If I do that right, let me count that again and just make sure I did that correctly. Here's 360, 450, 540, 630, and I have to go 10 more. So this is 10, but we're not looking for this angle. We're looking for the angle formed by the terminal side and the nearest x-axis. Well, I know if this is 10, this has to be what? 80, right? Because 10 degrees plus 80 degrees forms this 90 degree angle. So we went 360 plus 90 is 450, 540, 630. If we went to 640, that makes this a 10 degree angle. Means that this, what we're looking for, between the terminal side and the nearest x-axis has to be 80 degrees. So our response would be the reference angle is 80 degrees. Okay. Yay. I hope that makes sense. We just rotate, count, and once we get to where we are, we try to figure out, well, if this is at a rotation of 640 degrees, what does this angle have to be? What does this angle have to be? Just by counting. And hopefully you won't make a mistake like I did. I think I made a mistake here. Just count. Hopefully you'll count correctly and determine the measure of the angle between the terminal side and the nearest x-axis. Terminal side, nearest x-axis. All right. Hope that made sense.